All right, so I am Mohammed Traore. I'm a product specialist, sales development representative at Roboflow. And this is the Roboflow and Streamlit webinar using computer vision for logo detection. And also have Jacob Solowitz, Dr. Marissa Smith, and Snehan Kekri. Did I say that
Yeah,
correctly?
that's right.
Oh,
Yep.
perfect. Awesome. With me here. And so Marissa and Snehan are from Streamlit, and Jacob is also from Roboflow. And I'll let them give their introductions as well.
Sure, I'll go ahead and go first. So yeah, Jacob from Roboflow here. I'm a machine learning lead at Roboflow. And the quick, super high level view of Roboflow is that we make it really easy for developers to transform images into trained computer vision models that they can then deploy. And we also make that whole cycle of building and retraining your model and redeploying a very seamless process. So you can kind of build on top of our computer vision ML infrastructure and take your applications to the next level. And I'll pass it over to Marissa.
Hey everyone, so I'm Marissa. I am the developer, or one of the developer advocates now at Streamlit. Streamlit is a Python package that essentially turns your data scripts into shareable web apps in just a few Streamlit calls and in a couple of minutes, and it's all in Python. And I'll pass it off to Snehan.
Hi, I'm Snehan. I work at Streamlit as a documentation writer and also on the developer relations team. And I helped write the app we're going to show you today with the help of Marissa.
Awesome.
All right.
Awesome. Yeah. So before we get into all the awesome details that are present within Streamlit and within Roboflow, before we go into the in-depth details of our demo today, we kind of want to show you the end result. So I guess the quick story is Marissa and I got together and we were wondering what we should do for our webinar to kind of show our demo our different tools. And so we thought it would be really cool to create a logo detector that could detect both Streamlit logos and Roboflow logos, and then not only create this computer vision model that could, inference on a single frame, but rather deploy it live into a web browser. And that's one of the things that Streamlit makes extremely easy. So I'm going to go ahead and have Marissa show you this wonderful thing that we all built together, and then we'll take apart the internals afterwards.
Okay, I think you guys should see my screen now. I just turned my camera off in the Zoom, but that's just because I'm about to use my camera in this Streamlit app that connects to Roboflow. So just getting that up and going. So hi, I should be live now. And here we are. There we go. Live logo detection, if I can get my orientation correct here. There we go. That is what we spent a bunch of time building. We are very excited to show you how we got everything working here. Okay, I will pass it back to Jacob to start the nitty-gritty.
Awesome. Well, let's commence. Hopefully you guys thought that was pretty cool, inferencing live in the web browser. Obviously there was a little bit of lag there because like the Zoom streaming is probably slowing down some of the frame rates and things. But it's pretty cool. This is something we put together in, a matter of a few days together, just like a few hours over a few days, but pinging back and forth. So I'll go ahead and dive in on the Roboflow side of how we actually created this model. So if you go ahead and check out the Roboflow, can everybody see my screen first of all? One of the panelists want to let me know? Okay, we're good. So if you go on roboflow.com, you can sign up and then you'll enter into the Roboflow app. And I'll go ahead and just give you a little tour around here. So you have workspaces where you can work on different projects, and within those workspaces you have projects. And so if you kind of came in here and you had an idea of, okay, we want to create a Streamlit logo detector. The first thing we need to do is to gather images that are representative of the objects we want to detect, and particularly these should be representative of the deployment environment in particular that you're going into, and anything that your model might encounter you know, where the webcam is deployed, where your model might encounter things that are that it's viewing. So the first thing that we did was Marissa went ahead and open sourced or crowdsourced a bunch of Streamlit logos from people on her team. So we can go ahead and here imagine we've gathered a bunch of images and are ready to start working on our project. So I'll just call this project logos, and we'll give it the annotation group logos, and we're going to try object detection here. There's a few different types of computer vision models that you can build in Roboflow, but the primary one and the one that we see people getting the most usage from is the object detection type. So you can create that project, and then here there's a few steps to creating a model. The first step is you need to upload images. And then after we upload images, we'll annotate them. Then we'll formulate a data set and run training. And then I'll show you how the deployment options unfold after that. So in the upload tab, we can go ahead and here and select files. And in my downloads here, I've already gathered the images that Marissa so wonderfully gathered for us. So we'll go ahead and gather all of these, or I'll drag and drop them in. And so you can see as your data is loading in, you'll see your images appearing in the upload screen. And then you'll also see if you have pre-annotations, you'll also see those coming in, and you can take a little preview of those images and go ahead and upload them. We support a ton of different annotation formats. So if you're coming from somewhere else where your images are already annotated, those should automatically match. There's something like 35 or 40 different annotation formats that we've constructed over the months and years here. So here you can see this is where your data set is now for annotation. So imagine we hadn't already annotated this data set. The next step here is to go in and start to annotate, that is tagging with the annotation tool, the objects of interest that you want to be detecting. So this is the part where you're kind of really via annotation, you're teaching your computer vision model what you want it to be able to detect. And here, this data set is just primarily focused on the Streamlit logos, as you'll see here. And so this was kind of our first iteration, was going through and crowdsourcing all these different Streamlit logos, both white and dark logos, to see if we could build a model from this, a general model, you know, that as soon as it would pop up in Marissa's room there, it would be inferencing and able to detect the things that we were training in. A couple other things here: you have your training set, you have a validation set, and a testing set. The way to think about these is your training set is the part of your data that you're teaching your model with. And then the validation set is the thing that you're evaluating on as you're training your model to see how well the training routine is doing. And then the testing set is kind of like the final boss, the one that you don't show your model at all during training, not even for evaluation, and you test it on the final step on the testing set. So once you feel like you've kind of started to construct a pretty good data set, I like to just start with a skeleton of a data set in the first pass, and then continually iterate on that and create a larger and more robust data set as the project goes on. Then you can go and you can create a data set version. So this is where from all those annotations and images, you'll be creating a data set version, and this will be the thing that we'll send into a training routine. So to create a data set version, there's a couple things we need to decide. There's pre-processing steps and augmentation steps. The nice thing in Roboflow is you have all your pre-processing steps that you can easily apply to a data set version. These are things like resize, static crop, grayscale. There's this filter null if you want to filter out images that are all null. And you can go ahead and pick those to apply, and this standardizes across your training, validation, and your testing sets. Now, augmentations, this is basically image manipulations that you can do to your images to increase the size of your training set. So you'll go through here and you can like make way more images from the small base set of images that you made. Like you can do random crop, you can do rotate. So I guess for this one, it might make sense that the logo might be slightly tilted or slightly zoomed in or out. So crop, I think, makes sense. I also think that, yeah, the rotations make sense because the logo could manifest itself kind of in various ways. And then after you've kind of gone through and thought about some of that stuff, you can generate a data set version, which we'll do here. I'll just call this V1. So as this is processing, your images get sent into our backend. We do a bunch of image manipulations and the version gets saved. Now you can view the version images here. Like this one looks like it was rotated, if you want to get just a sense of what happened during the augs and the pre-procs. After you've assembled your dataset version, now you can click training. So this is where you start training. And we'll just go ahead and start training from scratch here. Your files get zipped up and they get sent into a backend server that runs a training routine. And this is the part where the model is going to actually be learning sequentially by iterating through your data set, what you've annotated and the things that you want it to detect. Another thing here that I want to point out is you can also export your data here. You can export your data set if you want to get the raw files. And if you want to experiment with training outside of Roboflow, we have this area called models.roboflow.com. But if you want to follow through with everything that we have, everything that we are doing in this tutorial today, you want to train in Roboflow. And you'll see after training, this usually takes anywhere from 15 minutes to 24 hours, depending on the size of your data set. For 350 images, will probably be about 10 or 15 minutes for the GPUs to do all of the work that they need to do. So thankfully, I've got things more or less pre-baked for us here. After training finishes, you'll see an endpoint that pops up along with some evaluation metrics. So this endpoint, you can now pass raw images from the wild to hit, to receive inference, to get your detections back. And then you can integrate this into your application. And there's a number of deployment destinations. So you can use the web hosted API through like a web app, as we're going to do today. And if you need that's a little bit more edge accelerated, you can put this on edge devices like the NVIDIA Jetson or the Lexanis Oak device. And those are all different deployment destinations that we have for you, and model conversions that you can get your model in different formats coming out of Roboflow. And so now I want to talk a little bit about a bit more about data set evolution. So we've got a model, we've trained it. It looks like it's doing pretty good. But now Marissa and I decided, you know, the Streamlit logos are pretty cool, but we actually wanted to make this so it would detect both Roboflow and Streamlit logos. So the way we did that was we created a new dataset version. And this time we uploaded a bunch of Roboflow and Streamlit logos, which are down here at the bottom, and combined those data sets into kind of a combined version of the data set. But we noticed that, you know, a lot of things were getting detected that were just like logos in general, like the McDonald's logo or some of these other logos. So we actually added in a bunch of null logos. That's addressing an area that I'm sort of passionate about, called out of scope training. So it's always important to think about that when you're building a computer vision model, is what are the edge cases where the model is going to be faultily identifying things, and then you can actually provide examples to guard against that. So that's what this version is. This is the merged logos data set, and this is going to be the actual model that goes into the Streamlit app that we're building today. One last thing I want to show you before we jump over into the Streamlit integration is, after you finish training your model and you have your model endpoint done with all of the results, you can go into the Roboflow inference example, choose the model path, the version, and then your API key. So this API key, I think, is the same one that Snehan has. We'll make this live for all of you guys so you can test out this app. But if the inferences get skyrocket too high, I'll have to shut it off. But we'll see how much people end up using it. But yeah, so you have your model endpoint, the version, and the API key. that's all you need to start running inference essentially. So this web app just makes a post request against this model endpoint. And we'll just select a random file. So this is from our test set, as I mentioned, like the final boss. Here you can select image if you want to see how it's doing on an image. Takes a little while for your model to heat up the first time it runs, and then it runs a little faster. So this one, we're not seeing any detections, but we could try turning down the confidence maybe and see if that works. Yeah, there's a confidence there. They just think or there's a detection there. It's just the model's not super confident of it. The other thing you can look at is the Json response. So this will give you the Json response that you could integrate into an app, as we'll be doing here in the next step. So yeah, so that's pretty much it from the Roboflow side. You can upload images, annotate them, train a computer vision model, and then deploy that computer vision model. So I'm going to pass it over to Marissa to take us into the next step, which is the actual model deployment process. And this is really exciting stuff. I remember picking up Streamlit like 2 years ago when all I knew was Python. I didn't know any web framework languages. And I was like pretty amazed at how easy it makes things. And that was even 2 years ago. So get excited.
All right, and it doesn't look like we have any current questions. One we had earlier was whether this would be available, and yes, we are recording it, so we will have it available for everyone afterwards.
Okay, so I'm just going to, share my screen if I can get that, click the right part of that button. There we go. Okay, hopefully you guys can see my screen now. Give me a thumbs up to the panelists if you can see it. Yeah, okay, I see some thumbs up. Okay, so now that you have trained your model with Roboflow, let's see how we can take that model, turn it into a local web app, and then take that straight through to deployment using Streamlit. Oh, let me just click into my, there we go. Just in case anybody is unfamiliar with Streamlit, Streamlit is, once again, a free open source Python package that is used to make web apps out of your data science or machine learning projects. All you have to do is download it to your computer, and it acts just like any other Python package. You import it to your script, and then you add Streamlit calls in various places in your app to immediately display graphs, data, headers, and even interactive widgets. Streamlit handles all of the difficult styling, leaving you with a super streamlined, beautiful app with minimal coding. Now we have our Streamlit Cloud platform. This is a platform that you can use to deploy your web app in one click. Our platform has multiple tiers, but there is a free tier called Sharing, and that lets you launch 3 apps. All you have to do is connect your GitHub account to our platform, and then any project repos that you have can be deployed immediately with one click and shareable to anyone. On your sharing dashboard, you would select the repo from a drop-down menu. You put in your file name or path, and then you just hit deploy. It really is just that easy. And I will show you in a minute. But just before we jump into the demo, I wanted to show you guys how you can actually get in on this deployment fun. So the first step would be to visit streamlit.io/cloud, and there you'll be able to sign up to our platform. Within a few working days, usually 2 to 3 working days, you'll receive an email invite that your account has been successfully set up in our system. And that's it. Then you'll be ready to deploy your own projects. Okay, that was a super short slideshow, probably the shortest in history. I feel like it was like, what was that? A couple of minutes. So I'm going to jump right into the demo here, and I'm just going to escape out of that. So the first thing I'm going to show you is my GitHub repo, which is here. So this is our Streamlit Roboflow demo repo here. This is what a typical machine learning or data science project might look like. Here on GitHub, we have our README displayed. This is quite short because I'm going to be taking you through all of the steps that you need to know here. We also have, of course, a requirements.txt. This allows our Streamlit Cloud platform to understand all of the Python packages that you need to install to make your app run properly. We also have an app.py file, and this of course holds the bulk of our script or machine learning model or /app in our case. And the other thing that I wanted to point out is that we have a .streamlit folder here. Now, posted publicly in this folder, we have a config.toml file. This config file tells Streamlit what colors to use, which means that you can change the colors from the default Streamlit colors into something that is more reflective of maybe your personality or the app that you're trying to put out. For example, we used some of the Roboflow's purple colors in our app. Now that is what's published publicly, but if I show you this same repo on my computer, my local copy of that, so here it is, this is an Atom editor. I've got my Streamlit Roboflow demo here. And you can see here's all the same files that we had before. Here in our Streamlit folder, we've got, of course, that config file that I just showed you, but we also have this secrets.toml file. And this is important because this is where we've put that API key that Jacob was talking about. That API key is a secret, and we will be able to keep it a secret and not post it publicly, just in case you wanted to keep that endpoint or that key away from any prying eyes. So I will show you how to do that in just a moment. So we have an app. You've seen a quick demo of it, but let's show you how to bring it up locally, because that would be the first step to actually deploying. So what I will do is I will bring up my terminal here, and you can see I am currently in my Roboflow demo repo. If we take a look, here's the requirements, and here is our app.py. Now, to make this run locally using Streamlit, you would do Streamlit run, and then the app name, which in this case is app.py, and then hit enter. And then this immediately brings up our app in your browser of choice. So here it is. Here I can select the device. So I'm going to switch this to my FaceTime camera, this camera here, and hit OK. And then I'm just going to turn my camera off in Zoom because it was just taking a moment to do all of that. So I'm just going to pause my video here and then jump back over here and restart my video on this side. Okay, hopefully everyone can see me. I'm not quite sure how slow that is going all the way to Roboflow and then back to Streamlit and then over to Zoom. And here, this is where we can start doing some detections. So there you go, the white logo. I'm turning it the wrong way, it's all backwards to me. So you can see the white logo there as I move it around. And of course, we have the Roboflow logo itself and the normal Streamlit dark logo here. And you can see many instances being picked up on this sock. Now notice here that we've coded this so that each detection or each class has a different color. So Roboflow's is green and Streamlit has a dark purple for its dark logo. Now, let's see if I can do this with one hand here. There we go. So here on the side, we also have sliders for the confidence threshold and the overlap threshold. The confidence threshold is just, as Jacob was saying, how confident our machine learning algorithm is that it's actually detecting a logo. So if we increase that, we'll see a decrease in the number of logos that are popping up. But if we decrease that, it will pick up pretty much everything, even the partial ones. And it's less confident on which one it actually is sometimes. There's also a distance factor in this, like I'm nice and close to the camera, but if as I back off, we'll see less and less detections, even with that confidence threshold very low. Probably shouting now. Until finally, there's pretty much no detections. Now, the other thing that we have here, which I'm just going to turn this confidence threshold back up to a more reasonable 50% there. So the other thing that we have here is this overlap threshold. So that is the distance between the bounding boxes that you can have. So As you increase this, the distance actually gets shorter, and you'll see that it'll start doing double detections here. Oh, let me turn this right up to 95% and you'll see this. Yeah, so you can see how they have some of them double boxes, and that's just because of the overlap threshold. As you decrease that, that gets less and less overlap, allows less and less overlap for your detections. Okay, so I'm just going to stop this here now, and then I'll start my video over here again. Pop back up, there we go. Okay, so we have our app, it's running locally, and it's working quite well. So the next step is to then take it to its deployment. The easiest way to do this, believe it or not, is actually right from this app right here. Up in the top right-hand corner, you have a hamburger menu. At the third option down is a deploy this app button. So we're going to click that. That button brings me over to the share.streamlit.io deploying platform. And notice that I've previously logged in, so it recognizes me. And it's brought me directly to a deploy an app webpage. So you can immediately pick up the repository that we're deploying from, the branch that I was on, and of course, the main file path that I was using. Here's where we need to remember to add in our token. So here in advanced settings, we click this and we can see this is where we can pass in that secret. That secret will be accessible only from our cloud platform, and it will not be published publicly. So all I'm going to do is jump back to my Atom editor, copy my Roboflow API key, and then paste it right in here. I hit the save button, and then I'm ready to go. I'm going to hit deploy. So we affectionately call this our baking page. We are currently getting your app ready. We are handling all of that difficult processes in the back, installing all the requirements, setting up an instance on our cloud platform for your app to be deployed publicly to everyone. While it's doing all of this and collecting all of these requirements, I'm just going to show you the 3 dots down here at the bottom. This is a quick access menu that I think is very helpful to people. It includes an ability to download your log file here. So this log file right here, if you press this button, no matter where you are in the logs, it will download everything right up until that point. That might be helpful in case you had any questions about something, or if you ran into any issues for any reason, you'd be able to download that log file and take a quick peek through to help debug your app. There's also a reboot app here as well, which will interrupt the processes, but it will allow you to refresh your app essentially. And the app is already deployed before I've even gotten to the third option on this list. So I'm just going to quickly finish through the options and then talk about that. You can always delete your app here. Once you press this button, it does not automatically delete. You get an option to actually type that in just in case you accidentally hit that. We have a settings button here that allows you to control some of the settings for your app. Here, this will bring you back to your main Streamlit sharing dashboard where you can see all of the apps that you have deployed. And of course, we have some helpful links here, one to the documentation and one to our support email. Okay, so this button right here will collapse this little view here. You can always get that back by hitting your Manage App button at the bottom. So as long as you're logged into sharing as the owner of the app, you'll have that option. And there we go. This is now live on the internet on Streamlit Cloud's sharing platform. And I'm actually going to copy this and pop this right into our chat so that people can take a quick peek if they wanted to see it. Snehan, do you want to send, I think Snehan also has another copy of this app deployed as well. If you want to share that one, that link as well, that would be very helpful to people so they have multiple options to go to. Thanks very much. So that's it, folks. That is really how easy it is to deploy using the Streamlit sharing platform. Now, just before I sign off, I want to show you a little bit about the code that actually makes this happen. So I'm going to jump back to my GitHub here, and I'm going to get into my app.py file. Okay, so what I really want to highlight is that there are 267 lines of code that we have made mostly Snehan. I have to pause here just for a second to do a quick shout out to Snehan for doing such an amazing job with this app. He really stepped up and gave me a hand because I was very busy before he arrived and I wasn't able to get everything quite completed for this. So he is the one that made this such an amazing demonstration. He got all of this working for us. So 267 lines, and I want to ask all of you a question. Put your guess into the chat there. Out of this 267 lines, how many of those do you think are Streamlit calls that make this UI that you see here, this beautiful UI? How many of those do you think? Do you think it's 20, 40, 50, 100? Give us some numbers. We've got 12, 4 is low, 2, that's super low, 15, 42. Wow, lots of guesses here. 50, 10, 35. Wonderful. All great guesses. Randy is not cheating. He is taking a guess. He does not know the correct answer. All right, well, I'm about to show you. So we import Streamlit here as ST. So what I'm going to do is I'm actually going to look for st dot to find out how many Streamlit calls we've made. And it is a total of 7. So we have made this app, this beautiful app that you see, with less than 10 Streamlit calls that manage the UI. That is because Streamlit is really designed to work right into your workflow. You can decorate any, I was right, factor of 7. Well done, Randy. You can really make this work for any script that you already have. It's designed to work directly into your workflow. You can take any machine learning app or script or AI algorithm, and you can just decorate that with a few Streamlit calls, and then you'll be able to make a UI that looks very similar to this. Okay, I'm going to highlight just a couple of things in the code before I finish off. One of them being this portion right here. This is a Webrtc component. It's a Streamlit component. You can think of Streamlit components a little like plugins. They give you added functionality to Streamlit's core base. They are slightly different than our core product when you actually just download Streamlit itself, because these are things that are made by our really active community, and they are made and maintained by those community members. So this is an example of one of those, and this community member made a Webrtc component that allows us to do and connect to our cameras. So a few highlights that I want to make is right here, we've set up some of the Webrtc client settings. Notice in particular that this component allows you to, of course, do video like I just showed, but it also has an audio component. We've currently turned that to false, mostly because of the negative feedback that we get when my voice is on the video and on the audio there as well. And then this app jumps directly into the main function, where you see the first Streamlit call here, where we make the header. So when in this one single line, you're able to actually create this entire header. Streamlit manages all of that, manages all of the visuals for you. So you just tell it what type of header you want, and it determines where it goes, what's its size, etc. From there, we jump directly into the logo detection part. So this part, we do all of the logo detecting in. I just want to show that some of these Streamlit calls here. This is where we set up the sidebar. So the rest, 1, 2, 3, 4, 5. So 5 of the 7 calls are right here, and they're all setting up that sidebar UI. The first one makes another header right here. And then of course we add the 2 sliders in, one for our confidence threshold and one for our overlap threshold. And then right underneath that, we added images for the Streamlit and Roboflow logos so that we can see them right in our app. So in those 5 calls, we have designed this entire panel right here. It's done. The rest of this is setting up some of the query parameters for talking, of course, to our Roboflow endpoint. First off, we actually just set this to 720. That is our resolution. We set it to 720 for a couple of reasons: to increase the speed of our app, especially while I'm running Zoom at the same time on my computer. And it does a very good job, as you saw, of still detecting the logos. So we were able to leave it there. You can increase that though as well. We of course set the URL base. So we know that our API endpoint is at roboflow.com. So we're telling it where to go. And then we give it the endpoint that we have. And then the very final Streamlit call that I want to highlight here is accessing the secrets file. This st.secrets looks specifically for that secrets.toml file that I showed you earlier. And it looks for something called an API key, and then it pulls that key in and everything is secure. So here we've defined a Roboflow video processor class, and this is where we set up the class. We annotate the image here. And if we want to go in any more detail of this, just ask in the questions. I can do a little bit more of an in-depth overview. But this is where we get the box. This is where we draw the name of what it has been detecting. Is it Roboflow? Is it a Streamlit logo? And here, this definition is the one that receives images and sends information back and forth from Streamlit to Roboflow. So that is what we're doing right here. We construct the URL, we send that URL, and we get our predictions back from that. And then we pass that directly into the last part of our UI, which is the Webrtc Streamer, that component that I was telling you about. So with this one call right here, with these few settings, we get this entire UI with the 2 buttons to start and select your device. And everything is fed in through here. The mode for our Webrtc Streamer is set to send and receive information. So it's sending images and also getting images back, which is how we get those annotated logos. And of course, we set our client settings with video on and audio off. And then we pass the class that we made to process our actual video. And that's it. That is how you take a machine learning algorithm from Roboflow and deploy it in just a few lines of code. Thank you so much for your attention, everyone. I really appreciate it. And of course, if you have any questions, we're around for the next 15, 20 minutes. Thank you so much for your time. All right, I'm going to stop sharing just now. There we go. All right.
Thank you. So it looks like we do have a few questions, and so one was someone was a little confused and asked if Streamlit is linked to Roboflow Universe.
No, Streamlit and Roboflow are 2 independent companies. We're not linked to the Roboflow universe, although we kind of partnered with them on that and gave them our data set for detecting the logos.
Yeah. So then everyone, that data set is available on Roboflow Universe. So you can go to universe.roboflow.com to make an app such as this with pretty much any of the ones available on there. And if you make a public workspace, then you do have higher image limits to begin and can immediately start porting those things over, do custom model training, whatever you need. Contact us as well if you need anything. And if you do that sandbox workspace, kind of have some of those same options as well. The next question we had was someone wanted to build an app that can identify many different kinds of Pokemon cards. Which model would be the best choice for this task? So I think it's kind of asking about whether going to classification or object detection.
Sorry, is that a question for me? I was a little distracted.
Oh, sorry. Yeah. Wanting to build an app to detect many different kinds of Pokemon cards, and which model would be the best choice for that task?
Yeah, definitely. Well, I guess it just depends on if you needed any localization when you were detecting on the Pokemon cards, you could train an object detection app, but otherwise that sounds like a classification task. And I do know that one of our fellow coworkers at Roboflow, Robert, trained the Pokedex 150, and he got 100% validation accuracy with the Pokedex 150. So totally possible.
So we had another question, which was, what are the limits to GPU usage for cloud models?
Yeah, sure. So I guess that's probably for us. So GPU usage, if you create a public workspace, you have more image limits, but the GPU usage still is something that you need to share your data set on a Roboflow universe to access the GPU training. And then also if you're in a sandbox workspace, you can have a few trains. But otherwise that's like we have you reach out to us and then start training with us. Otherwise, the Colab notebooks that I shared earlier, you can train all your models on Google Colab and use all their GPUs. And then I also assume that Streamlit does not have GPU auto scaling stuff yet. So I couldn't imagine how many apps they would have up on GPU if that was the case.
So I have another question of any suggestions on video processing with Streamlit?
So it maybe Pavan could be a little bit more direct. What do you mean exactly? What are you looking for your video processing? Are you looking to try and speed it up, or?
Yeah, I'm guessing it might mean like uploading video like into the app and then the detections on that.
Okay.
Yeah, yep.
I upload a video in a shared app. Snehan, what do you think about this? It takes a lot to process it.
It's completely doable. I think there are hundreds of apps in the object detection machine learning category where we have a file uploader widget that you can upload videos to, and then the rest of the video processing is done in pure Python. Use your favorite video processing package and perhaps OpenCV to do the video processing. And I think a lot of the compute power is really dependent on the host, as in what machine your app is running on. So if your app is running on a machine that has access to GPUs, you can use your favorite Python libraries to connect to the GPU and do your video processing there. And if you want to speed up processing for videos, I think there are many ways to approach it, including downscaling the size of the images that your model is seeing, and so forth, and perhaps collecting a buffer of images and doing it asynchronously. Yep.
Thanks, Neha.
I like the async idea. If you use the Roboflow inference API, you can post as many asynchronous calls to that as you want. So that can relax the whole thing.
Then the next question we'd have is, can Streamlit apps be hosted on any domain or subdomain?
Oh, like a different cloud platform?
I believe so.
That's
so
what that sounds like to me, I think. Yeah, it can. And there's lots of people who have actually hosted it on AWS or Heroku. This is just our own platform that's designed to integrate directly with Streamlit so that you can hit that deploy button and make it work. To do your deployment the way that I did it, by hitting that deploy button, you do need to use our cloud platform, but there are definitely multitude of other ways to deploy Streamlit apps if that's what you were looking for.
Maybe this is maybe the way that I interpret, or I'm curious on this interpretation of the question, but can you remap the domain name to, like, say if you wanted to host it, say I wanted to host that app on roboflow.com.
Like, would you be able to change
like instead of having it say
that deploy button and change it to go to Roboflow?
Or like when you go to the web app, like address URL, can you host that on your own URL? Or is it on share.streamlit.io?
No, it's on share.streamlit.io.
Okay.
Yeah.
So essentially like compiling the code within that GitHub to like Heroku or AWS. Yeah. Okay. And then Do we have any other questions on the process or on how you can sign up for Streamlit, how you can sign up for Roboflow, or the types of accounts to make, whether it's share, public, or sandbox? Okay. One quick question I would have is, it's like, so I have an app on Streamlit, and then I update it in Roboflow. Would I want to make sure I retrain it before I do anything else in Streamlit, or is it just okay to just keep going from there?
That's good.
So, oh,
Yeah.
go ahead.
Yeah. So I guess on the Roboflow side, yeah, you should definitely retrain your model after you've made like data set edits and such. And then you'll get a new URL, or you have the same endpoint, just a different version URL. So we could, so you need to update your Streamlit app with that new URL to post to.
Yeah, and I was just going to say that as long as you haven't changed your endpoint or your API key, then it will work fine. But you can always go back into your code and update that endpoint. If you retrained your model and then you have a different endpoint or a different API key, if you update that secrets token and then update that endpoint in your code, and it'll then reconnect for you.
And then we also have, is it possible or easy to add like a paywall for the Streamlit app, like if they have it on the sharing platform?
Yeah, I think it's possible. It hasn't been tried a lot. There's been a number of people that have kind of talked about this on our community forum. So our community forum is a place where people can go and ask questions directly about Streamlit. Actually, let me just grab the link for you guys there as well, because I know that there has been a couple of community posts about, taking payments in Streamlit. I'm not sure how successful anybody has been with it, but I think it's not out of the realm of possibility, but I don't think it's going to be particularly easy. I couldn't really touch on the complexity of that because there's so many multitude of ways that you could go about it. But I would actually take a search through our discuss.streamlit.io link that I just sent you there. That's to our community forum. And there have been definitely posts in the past about people who have talked about how to do a paywall in Streamlit.
And then, okay.
Oh, yes, of course. And we do. Thank you, Randy. We do also have paid cloud tiers in our Streamlit cloud platform that you can limit who can see the app with O authentication and SSO.
Awesome. And then if we have any other questions, have a few more minutes for them. Otherwise, not looking like we do. I just want to say a big thank you to Snehan and Dr. Smith here, our friends from Streamlit, and also to Jacob for that great demonstration, and also just for making sure these data sets and the code are available. So everyone remember, the code is available on GitHub, and then the data set is also available on Roboflow. But actually, we have one last question that just came up. How easy is it to build a web page like imdb.com and use as an using Streamlit? It's like, I guess, so they wanted to build more of like a web page with the Streamlit calls.
Yeah, so it certainly is possible, especially with our new release feature of session state, which allows you to store values between reruns of Streamlit. So what happens when Streamlit actually runs is that when you interact with a widget, it runs a script from top to bottom again with those widgets' updated values. So what we've allowed with session state is allowed you to store specific values so that you can do more complexity to your app. Now, we don't currently have a Streamlit built-in UI for like a top bar, but we have the sidebar. And then you can use different things like radio buttons to create pages in your app that run entire scripts from one central location. I have actually done this previously. So you can add a fair amount of complexity into your Streamlit app with just the built-in functions using state, and then of course, all the components that we have available.
Thank you. And all right, Venkat also says, thank you very much. So you guys have been an amazing group of participants, and compiling this for that cloud version right after this, and I'm going to be sending it over to the Streamlit team, and then we'll also have it available so then we can have this posted for you all. But we do also have a chat feature on that sign up page. So if you are looking for the link to the video sooner rather than later, should have it available up there about the next half hour or so as well. And just thank you all so much for all the great comments and for attending, and hoping to do one of these again sometime soon.
Thank you so much, guys. Very excited.
Thank you. Have a
Thanks
good
for
one,
your time.
everybody. Cheers.
Bye.
Bye-bye.
Cheers. Bye.